Welcome back. In the last video, we are solving the APDCL JE 2021 question paper. I have solved around 8 questions there. You will find the link of the previous video in the description below. Continuing with the video, we'll start with the next question, that is question number 9. Here it is given we have three voltages VR, VYN and VBN. Okay, we need to find out the phase sequence. So if this is VRN, then we have VYN is, the question is not given here properly, VYN angle plus 120 degree. Okay, so it will be in this side, this is VY, and VBN is minus 120 degree. So this is VBN. So the sequence will be RBY. So option B will be the correct answer. Next question, the question here is given there. We have a phase voltage given as VR and VB is given. We need to find out the line voltage, that is VRB. So VRB will be equal to VR minus VB. Now if we solve this, we have to write 100 angle minus 120 degree plus 100, it will be angle 120 degree. If we take 100 common, 100. Now if we solve this, cos 120 degree plus j sine minus 120 degree, the cos term will be cancelled out and we'll have minus j sine 120 degree. That we'll get 173 minus j 173. So the correct answer will be 173 angle minus 90 degree. So option A is the correct one. Next question, it is given three identical resistors connected in star are carrying a line current of 8 ampere. If the same resistors are now connected in delta across the supply, the line current will be. So we know that IL star by IL delta equal to I by 1 by 3. So we have line current is 8 ampere. We'll multiply with 3, we'll get 24. So 24, the option 3 is the correct one. Next question, this question is not given properly. All the values are not given, so we'll skip this question. Similarly with this question number 13 also, you can skip this. Next question, we have question number 14. The total impedance as seen from the supply terminals of the circuit figure is this. We need to find out the total impedance, that is Z. To find out Z, here Z will be equal to what? It will be with the parallel combination of these two branches and it will be in series with this. So if we have to write, suppose this is Z1 and this is Z2. So it will be Z1 into Z2 by Z1 plus Z2 plus, if you take this as Z3, it will be Z3. So when we will solve it, we will get 7 plus G 0. So option A. Next we have an AC voltage of 200 volt at 50 Hz is applied to a coil which draws 5 ampere current, dissipates 1000 watt. The resistance and impedance of the coil respectively. So we need to find out R. We know that P equal to I square R. So I square is given, current is given 5, P is given 1000 divided by 25. We'll have our R here. So it will be around 40 ohm. So this is, we have the value of R. Next we need to find out the impedance. Impedance, it will be 200 by current, it's given here as 5, then again it will be 40. So option 40 A is correct one. Now the next is given here, again the following we have to match it. So we have three forces here: deflecting force, controlling force and damping force. These three forces are used in the instruments. So deflecting force, it is used to deflect the pointer. Okay, so it will be because of the base option is a current coil. Now controlling force, this force it is acts in opposite to the deflecting force. So we have two types of controlling force. One is spring control and another is gravity control. So we have here only spring, so controlling force will be spring. Now the damping force, this is used to damp the oscillation of the pointer. Okay, we have different types of damping force like air friction, fluid friction, eddy current friction and electromagnetic friction. The option given here is fluid friction. So this is the correct one. So from the options we will have option C as the correct one. Next, to measure the resistance of an ammeter shunt, which of the following method is best suited? So ammeter shunt, it will be have low resistance. Now from the options we can see here, ohm meter method, this is for the medium resistance. Wheatstone bridge, again medium resistance. Kelvin's double bridge, yes, it is for a low value of resistance. And loss of charge method, this is used for high value of resistance. So our correct option will be option 3, that is the Kelvin's double bridge. This is used for the resistance of an ammeter shunt. Now the next question, we have question number 18. It's given here that the resistance of a voltmeter coil is 10 ohm and the current for full scale is 15 milliampere. The value of resistance to be connected in series with the instrument to enable it to measure up to 150 volt. So we have to connect in series. So the formula here we can directly write it RSE. The value of the resistance will be equal to the resistance already given into M. M is the multiplication factor minus 1. So we have R is the resistance is given here 10. So what will be M? M will be the voltage, it is given here 150, and we have the total voltage, it is given earlier is 10 into 15 milliampere. 10 into 15 milliampere, it will be 150 into 10 to the power minus 3 minus 1. So if we solve it, we'll get 10 into 999. So answer will be 9990. So from the options we can see option D is the correct one. Next, we have which one of the following is not true for sulfur hexafluoride? Not true. So from the options we can say it is yes, it is always a electronegative in nature. It is high dielectric strength. It is non-toxic. It is highly inflammable. This is not true because it is non-inflammable. Sulfur hexafluoride gases are non-inflammable. So our correct option will be option 4, that is it is highly inflammable. This is not correct. Okay, next we have silver is not used as a conductor because it is a very, silver can be is a very good source for, can use as a conductor, but the main reason we don't use as a conductor, it is because it is very expensive. So from the options it is given here, yeah, yes, it is a costly material. Next question we have a, here is in a 11 kV 415 volt 3 phase delta star transformer, the tappings are generally on the tappings are always taken on the middle part of the high voltage side. So we have here the high voltage side. So option C will be the correct one. Next, it is given here the mutual flux in the core of a transformer on no load is 1 Weber, is loaded at 0.8 power factor lagging. Then the mutual flux it will remain constant. So it will be option C. Next we have a transformer turns ratio. Again this question is not completely, we can see here the question is not completely given, so we'll skip this question. Next question is question number 24. The flux involved in the EMF equation of a transformer. EMF equation, we know that ERMS equal to 4.4 phi m, that is the maximum F into N. So we have the flux here is the maximum flux. So the flux involved in the EMF equation will be the maximum flux. This is option 3. Next, it is given a change in 5% in supply voltage of a 3-phase induction motor will cause approximately dash change in its torque. So we know that a 3-phase induction motor torque always varies to the voltage square. Now we need to change. So if it change means del T will be proportional to twice of del V. Now the change in the voltage is 5%. So 2 into 5 it will give you approximately 10%. So option 1 is the correct one. Next question we have the function of damper bars in synchronous machine. Damper bars in synchronous machine, it is used to prevent from running at synchronous speed. One is given, the second is prevent from running at super synchronous speed, prevent running at sub synchronous speed, reduce the rotor oscillation about the operating point. So it is used to reduce the oscillation of the this used in the for to damp the oscillations of the synchronous machine. So this option will D4 will be the correct one. Next is a synchronous condenser is given an overexcited synchronous motor driving a mechanical load. We can say that a synchronous condenser is one which is an overexcited but at no load. So we'll have an ordinary capacitor banks, this with no self extension and without mechanical, and no, it's not under excited, it will be over excited. So option 3 is the correct one. Next, frictional pitch winding in case of synchronous generators resulting. Frictional pitch windings, these are used for the split to prevent to have a improved waveform, okay, to have a better improved waveform, and it is also helps in reducing the copper loss. So from this option we can have better voltage waveform and saving in material, okay. If the copper loss reduces, the material saving can also be done. Next question, here it is given the function of the armature winding in a synchronous motor is it is always used to prevent the fluctuation, speed fluctuation or the oscillation. So it is either prevent hunting or provide starting torque. So it is will be the correct answer. Now, V curves of synchronous motion motor, so the relationship between, it is always so there's relation between the armature current and the DC field current. So from this 4 option, 3 will be the correct one. So this is the last question in this video. The shunt field winding consists of, it will always consist of the turns will be more and the area will be small. Why? Because more current will flow the R. If R is equal to rho L by A, if A is small, then what will happen? We'll have more, R will be greater, so more turns with small cross-sectional area is the correct one. Okay, in the next video we'll solve the another remaining 30 questions. Thank you.